Oh, good afternoon. My name is Sven Delariviere. I'm a beginning PhD student here at VUB. My area is philosophy, so this talk will be mainly philosophy. And I'm especially interested in the notion of mathematical understanding. And I've developed a framework for approaching this notion. And one of the key aspects of this is the subject, and I thought this would be an interesting seminar to focus on that a little bit more than I usually do. So, first of all, mathematical understanding is quite a valued aim. After all, when people study mathematics, or when they even prove theorems and reprove theorems, they're looking for some kind of understanding rather than just verifying. However, in spite of the fact that there is somewhat large agreement, at least in intuition, that understanding is an important motivation to do mathematics or even science in general, the philosophical notion of understanding is a bit of a mixed area, because first of all, not a lot has been said about it. This seems to me mainly due to the association it has with subjective feeling, which usually philosophers sort of want to dismiss as irrelevant. And therefore, a lot of work that can be related to understanding has been more fruitful or more explored than understanding itself. I'm thinking here of the topic of explanation, which is not that much explored either, topic of knowledge in epistemology, and recently scientific understanding. There is a bit of a growing movement there. It's, I think, only like 20 years or maybe a bit more that philosophers of science have begun to really take seriously the notion of scientific understanding, but mathematics is lagging behind a bit. We have one really good paper by Jeremy Avigat, who tries to characterize understanding mathematical proof. But other than that, most of the things that can be found will be in philosophy of mathematical education, which has some insights here and there, but their main focus is on teaching mathematics, which makes it less ideal for what I want to do. However, as I've said, it does connect to some other topics and even diverse fields such as philosophy of mathematics, epistemology generally, and even a bit of cognitive science. I would like to be informed by all of them a bit, to the extent that they have something to say about the notion. Now, this talk will be essentially a framework that I've constructed for approaching the notion. I won't say much about a contextual approach, but I'll say quite a bit about approaching it functionally. And the way I'll do it is by branching it into three main focuses. The first one that I'll talk about is the property itself, how we characterize that. Then I'll talk about the object, and then I'll talk a bit about the subject. And the way I'll do it is by first give a characterization of what it could mean, then go a little bit further into that with a bit of an analysis, but considering this is the beginning of my PhD, this will still be somewhat hand-waving directions in which the further analysis would need to go. And lastly, I hope to extract some parameters out of this analysis that can function as a way to express the quality of understanding. I call this generally a functional approach. I think you'll see why. I'm not entirely sure whether functional is the best word here. Maybe operative would be better, but I couldn't find a good definition of either of them. And Avigat mentions his approach as functionalistic, so I'm following him in here. If you guys have different opinion on this, definitely let me know afterwards. And there's also a contextual approach, which I will skip for this talk. Okay, so as promised, I will split this into 3 different branches: the subject, the property, and the object. I will begin with the property. I think the subject focus will be most of interest to the people here, but I will have to go through this to give the full picture a bit quickly. So, the property of understanding. As you can see, I've made really dynamic slides. This is not just for a gimmick. It's because it's helped me to create this framework. As I'm quite a visual thinker, it helps to structure it for me. And I hope that the way I'm presenting it will also help with an understanding. So it's a bit more than just flashiness. Anyway, so to begin, the property. What the property is and how we should characterize is what the subject possesses when we attribute her with understanding. This is regardless of what the understanding is about. So mathematics doesn't even come into play here unless by examples. And there's several ways that we can do it. I've already mentioned that the feeling of understanding, the subjective experience, or an aha-erlebnis is not a very good way to approach it, at least to characterize it. And this is one of the few points in the literature on understanding generally in science or anywhere else where people are in agreement that it is neither a necessary nor sufficient condition, so we can skip that one quite easily. Something that does get thrown up quite a lot as a possible characterization is mental representations or mental states. However, I have some problems with this because you can really only characterize a mental representation by its external traits, and we can't exactly. I mean, what exactly would be, for instance, a way to peer into someone's mental representations, if not by looking at the way the person behaves, the things that the person is able to do. And even worse, we can only evaluate these mental representations by their external fruits. So it would be very difficult to say what exactly would be the correct mental representation for understanding that the square root of 2 is irrational, for instance. Therefore, I would say just get straight to the external fruits, and let's characterize understanding as abilities, which is what Avogadro does as well, the one paper that I will be referencing quite a lot because it's important to me and it seems to align with the things I want to say. So there's a couple of advantages to doing this. First of all, it sidelines the feeling of understanding without necessarily, of course, discarding the feeling of understanding. If it plays a role in making sure the abilities are realized, then it is still important, but we don't characterize understanding as these feelings. The second 2 points are related to what I've said in the previous critique of mental representations. It's that the abilities are something which we directly value rather than what's going on in someone's mind, and it fits better with our justifications for understanding attributions, because when we are asked to motivate why we think someone understands, we're not trying to paint a picture of what's in their head, we're trying to talk about the things that they're able to do. And 2 minor pluses, which I quite like, is that it allows for tacit understanding, and it doesn't require possession of understanding at a particular time slice. It's a bit looser than that. Now, to give an example, I'll use paraphrased some of the things that Avogadro sums up for understanding a proof. So it's obviously being able to produce the proof, but that's not sufficient. There's other things that are involved in understanding a proof, such as, for instance, providing counterexample of what goes wrong when various hypotheses are omitted, identifying key features or arguments, nature of objects and questions, mustering some relevant background knowledge, exploring the space of possibilities fruitfully, maybe re-represent the same proof in a different way, and things like that. So now that I've characterized understanding or the property of understanding as an ability, we can look a little bit further into what an ability exactly is. I won't go too deep in this, but I side with the counterfactual theory of ability, which says that an ability is essentially the successful performance in a set of limited counterfactual circumstances. An analysis of this would specify a bit further what we mean with a set of limited counterfactual circumstances. But I think this fits very well with our intuitions. For instance, when we assess understanding, we're trying to identify these factual and evidence of counterfactual performances. I've given an example of this. Let's say that there's a student that always performs very well, but at this precise moment, someone is staring at her and she looks a bit insecure, and she's not able to produce the proof which she otherwise would have been able to. This is not a metaphysical problem to then say, I think she would be able to produce the proof if you wouldn't stare at her, in spite of the fact that you are obviously talking about a counterfactual situation. Now, with this in mind, we can extract some parameters, I think, specifically to do with the property then. And I think the parameters that I'll unfold here have to do then with the stability of the ability. There's two that I can think of. There's range and robustness. Range would basically be the amount of circumstances under which the performance is present. So for instance, if we're taking the ability to produce a proof here, then the person can produce the proof regardless of weather, time of day, location, etc. And robustness is essentially that the person can produce the proof again, regardless of some events or circumstances that were intervened in between. This could be time, just being able to produce it again in the same sort of circumstances, but slightly later, or someone trying to deceive them a little bit and they can still perform quite excellently in spite of it.
It's not very clear what's the difference between the two. Robustness.
Well, they're very closely related, but this is just where you would basically take the same person, but you put them in different circumstances, but the person doesn't really change. And this is if you allow some circumstances to sort of pass. That's the difference. Does that clear it up a bit?
You mean that you assume that during the time interval something will change within the person?
For instance, so maybe someone with a very bad memory just learned something. If you would put that person in a different counterfactual situation, he would be able to do it in all of them because he just learned it. But if you put some time in between, he's not going to be able to.
It's more kind of a stability.
Yeah, that's the things together would be what I call stability, and it sort of splits up into two. There's relations between them, of course, but I think it's nice if we can sometimes specify a little bit clearer for some situations. So that will be my property focus. I'm now faced with maybe some dissidents who might say, well, I can think of certain situations where there's abilities, but there's not understanding. And a nice problem of this, I think, is what Skem calls rules without reason, where you're just sort of following an algorithm to get at answers for a particular problem without actually understanding what you just did. And something that is akin to this is if you just memorize correct answers to questions, say something at the end of a textbook as a sort of example exam. You memorize this and then you can solve some answers, but you don't really understand what you're doing. My response to this would be that the problem here is not so much that you have an ability without understanding, it's the scope of abilities that you have. For this, I'd like to go to the branching again and specifically focus on the object. So the object is what the understanding is about. In mathematics, this could be quite a lot of things. We can understand a proof, we can understand a theorem, a concept, a problem, a strategy, and there are obviously several connections in these objects to other objects. They could be something could be a logical support for something else, an example, something that looks like something else, a re-representation, and so on and so forth. And if we want to characterize what the person's understanding is like, we need to know something about what the understanding is about. The way I've put it here is that if you characterize the object, which you could call its meaning, that will be relevant to understanding it, which would be, I think it's fair to say, capturing this meaning. Now, if you were to characterize the object of mathematics as a sort of timeless thing in a Platonic world, then you need to have access to this. This has much too heavy an ontology for me, so I'm going with characterizing it via its use, which sort of fits with the idea of meaning as use. Whatever it is that someone understands will obviously have several uses connected to it that are part of an institutionalized practice of mathematics. So capturing the meaning then would basically be having the abilities that exhaust these uses. There's a nice quote from Gondino, who I think says something similar. And he says, a subject has grasped the meaning of a concept if the subject is able to carry out the different prototype practices that make up the meaning of the institutional object. Now, obviously what I can't do with this is talk about understanding things that have not become yet part of an institutionalized practice. But this is a risk that I'm sort of avoiding because I'm not going to try and characterize understanding of something that doesn't even exist yet. This would be too difficult. I would need to make claims about what would become good mathematics, and that's something that I leave to the mathematicians, at least for now. So that will be how I characterize objects via their use. That obviously means it would, to know how much understanding is present, would benefit from analysis of practice about what is involved, which uses are involved or connected to a particular object in that practice. Now that is a little bit beyond the scope of my PhD and most definitely this presentation, but I can make two notes. One is fairly intuitive, that there are several uses connected to an object. So there will be several abilities involved in understanding that object. That may seem a little bit trivial, but that's one of the counter arguments for being able to understand with just an algorithm, because you're only really exhausting one use. The second note I want to make is that mathematics is a bit more informal than it is usually standardized as. And I'll give an example of this. So, for instance, proof in practice is not, at least not usually, just a complete deductive path from axioms to theorems. So if we want to have, sorry, the second point I forgot to mention, it is also not only of interest as a piece of verification, otherwise mathematicians would obviously stop at proving it once, but they like to compare proofs and have several. One of the reasons why is showing key ideas, how fruitful a methodology can be, or quite simply showing alternative routes. And if this is true, then we need to have an account of understanding that reflects this, which is why also that I like Avigat's list of different things that are involved in understanding a proof, rather than just saying you have to be able to produce the proof. Okay. So here again, we can extract some parameters, which I will call the scope of abilities. The first one of which is width, which would be outside of, for instance, producing the proof, the other list of abilities that are valued about, say, understanding a proof. This could be representing the problem, applying a key method elsewhere, such and such. Also the sensitivity, which is essentially the ability to respond correctly if something changes in the object situation. So I've mentioned the square root of 2 being irrational. There's a proof for this, but you could then ask the question, would this hold for 3 or 4 or 5? And the ability to respond to such situations I would like to specifically call sensitivity. It looks a bit like other requirements that have been mentioned in scientific understanding, like what ECCO calls counterfactual inferences, I call sensitivity. And just to be complete, I'd like to have an accuracy parameter, because I think it's very useful to distinguish from an educated and an arbitrary guess. Okay, so that will be my second focus. No, that was it for my second focus, I'm sorry. I'd like to come back now to the problem that I started this one with by saying the parameters are a means to express the understanding, but we have a problem, because if we are trying to assess someone's understanding, we are doing this on the basis of a limited set of performances. We can't look at the entire width, sensitivity, range, and robustness of a person. So we're really only looking at small fragments and trying to estimate the extent of the understanding that is present, which makes it susceptible to kludges, which is a term I quite like from the engineering and I think computer sciences, being a very quick and dirty tactic to solve a problem. It works in some cases, and sometimes the only cases that you need it to work for, but it has a very limited range in actually being successful. But obviously, if you only really see the limited set of successful performances, you could presume the abilities to be much wider in scope than they actually are. And I think that is essentially what the problem is with things like memorization and rule following. If you just ask the questions that the person learned by heart in the textbook, it will seem that they know what they're talking about, but as soon as you deviate from that a little bit, you'll find pretty soon that there's something wrong with their understanding. And I think that's also why this is not really so much a problem for the ability account, and rather just a problem of assessing it. Okay, so you may go further yet. You may say, okay, we could go further than just having one algorithm to solve a problem. What if there's an elaborate rule system, so complex and well designed, that any question that you can ask that person, it would just follow the rule system and get an answer? People may already have either read it or thought about it, but this is essentially the Chinese room thought experiment. And my response to this is asking who the abilities really belong to in this case. So we're going back to the branching, and this time to the subject. Right. If we want to characterize the subject, we have to specify who or what is it that possesses the abilities. I've added what here because I want to talk about subjects in the broadest sense of the term. I don't want to limit myself to just human beings, because obviously non-human beings might be able to have some abilities, and to the extent that they do, I would like to credit them with understanding. So here's the Chinese room, and here's what I would call the math room. It's essentially the same. In the Chinese room, we have Searle locked in a room receiving what are to him unintelligible signs in Chinese, and he's following a large rule book to produce answers which will convince someone outside that is a Chinese native speaker that he understands Chinese. The same thing can be said with math. You just replace the Chinese signs with mathematical questions, and the person follows an instruction book that produces answers that will convince a mathematician of his proficiency in mathematics. Now, is this then an instance of the subject performing without understanding? Well, it depends on what we are asking as the subject of understanding. Here we are assuming that S should be the person possessing the abilities, but that's not exactly true. So my suggestion is change the subject. Not in the evasive sense, of course, but literally the subject possessing the understanding. This is akin to the system reply to the Chinese thought experiment. Let's be honest about what actually implements the ability. It's not just Searle in this case, but it's a combination of Searle and that rule book. It will be the same in the math room. The subject, S, is not here the physical system possessing the abilities, but it is rather S and the book together. But Searle is one step ahead. He says, okay, but what if we let S internalize the rules? Well, that'll depend, I think, about what it means when you say internalize. What he means is memorize, and that's all very well, but then we can reply what is in the Chinese room thought experiment, the virtual mind reply, namely that in this case we will have two virtual entities. It's true that in this case, if we want to sort of draw physical contours of the system that has the abilities, that it will be around Searle's skin maybe. But if we're talking about Searle as a virtual entity, as a subject who has beliefs and desires and things like that, then we're talking about a virtual entity that is realized by his physical body. And the Chinese person that is responding to these questions is clearly not the same person as Searle at that moment. It's a bit like software running on hardware or software running on an operating system. They're not exactly like, of course, but the metaphor is very useful in making the point. And there's a nice example by Cole, which I like. So he says if we were to flesh out the conversation and we were to look at the questions that you asked a Chinese person, it may be something like, how tall are you? What is your attitude towards Mao? Then the answers to the questions that you'll get from the Chinese room are clearly going to be very different from the answers you would get from Searle, because Searle has an entirely different perspective on this. And it will be the same in the math room. So the perspective is, how I call it here, would be those of the rules rather than the rule follower. However, the math situation is obviously a bit tougher to differentiate the two entities because you don't have like two different languages. But there is a quote I found from Dreyfus on his model of skill acquisition. And he talks about different stages where a person gains proficiency in skill. And at some point in the beginning, when he's just sort of learning the rules, he doesn't really know what he's doing or what he's applying. And the more internalized it gets, the more it sort of shifts towards his perspective. So therefore, he says, if the rules do not work, the performer, rather than feeling remorse for his or her mistakes, can rationalize that he or she had not been given adequate rules. But because, at a further stage of competence, the result depends on the learner's choice of perspective, the learner feels responsible for his or her choice. He doesn't say it in the words that I would use. He just says perspective for the later stages, but I would say that the perspective in the previous stages would be those of the rules rather than the person following them, which fits rather nicely, I think, with the Chinese room thought experiment. So to end here, I would say that if we're talking about the virtual entity, I would call it a character, and the character that possesses the abilities in this sense is not Searle, but something else, or not the previous subject we've mentioned. Okay. So what does this tell us about characterizing a subject? There's two ways to do this. As a sort of physical system, well, obviously we don't do this by skin borders. I think we've kind of asked this. Anyway, it doesn't matter if something is under your skin. That doesn't make it yours just because it is underneath it. It depends on how it's connected to the rest of the system, which is quite a functional characterization again. I call this access and use, which is borrowed from Clark and Chalmers about extended mind, but I think it fits in rather well here as well. And for the virtual level, actually rather similar. We don't attribute something to the same virtual entity because it's under the same system. Because first of all, if it plays no role in the cognitive process, it doesn't really matter. And as we've seen in the rather extreme math room and Chinese room example, two separate cognitive processes can be implemented in the same hardware. So here as well, it is access and use, but between the virtual components at a relevant virtual level rather than just as a physical characterization. So here as well, we can further analyze what a system and a character means. So for a system, for instance, we can conceptualize components and their role in implementing an ability possessing a system. And one of the reasons I bring this up is because I think even if a component of a system has a functional role to play in the overall system, that doesn't mean that every role is equally relevant. So as an example for this, I'll take a weatherman's ability to predict the weather using some piece of data. And I'll go through them because I want to start on the opposite end. If he just repeats his colleagues' weather predictions, then his ability to predict the weather is sort of trivial in this instance, and after all, he's not going to be able to do it as soon as he's taken away from his colleague. So we sort of trivialize the role of the weatherman in this respect, his ability, and attribute it mostly to his colleague. It gets a little bit more interesting if the weatherman uses some complicated data software that interprets this data. Here we can definitely say that there's a combination of both the weatherman and the software doing the work. Slightly less the case if he uses the thermometer. I would still pair them, but we find that a little bit less interesting of a process. And the other end of the spectrum, he would be able to predict the weather on the basis of just looking at the weather at the moment. Now, I don't really know how I can keep the current weather out of it, because I did say that as soon as it plays a sort of functional role, we have to combine it in the system. And at the moment, outside of my own intuition that the role of the weather here is trivial, I don't know how to keep it out of it. So that's sort of a running problem for me, at least in a philosophical argumentation. Okay, we can also do a further analysis of the character. I've used what Dennett calls the intentional stance to get at the intuition of which virtual entity is one and which virtual entity is another, such as Searle and the Chinese person. But this should be developed, I think, a little bit further. Here.
You mean that the different characters or the different virtual entities do not have the same desires or the same beliefs?
Yes. But how to exactly argue this outside of showing some intuitions from what then calls the intentional stance, I don't really know how to do. So I want to investigate that a little bit further. How we specify this? How can we say this is clearly a different virtual entity, other than it very much looks like a different virtual entity? That's quite difficult. The second point is, this is where mental representations actually comes back in, but as an operational construct, considering there's quite a bit of similarity between people, or at least groups of people, we can talk about patterns in their beliefs in implementing the character that possesses understanding. And a last point is talking about how the parts contribute to the whole. And this is especially important in situations in epistemology, where, for instance, there is a debate, which I quite like, in social epistemology about group knowledge. So they're discussing whether or not a group has knowledge that cannot easily be reduced to just the knowledge of its members. And there's proponents of this, and there's people disagreeing with this. For this, I've sort of used a sort of very draft-like idea about reducibility relations, where you would have joint cognition. In this case, you would just be able to describe the abilities of the entire system quite easily by reducing it to its parts. That's just the case in some instances of group knowledge, where you say the group knowledge is by popular vote, so it's easy to reduce it to its members. But there are more difficult situations where you can't simply reduce it to its parts. The easiest example of this is that if a person contains knowledge, you can't ask for the brain parts containing the knowledge that easily. So we attribute beliefs to an entire person, not to brain parts. And the same could be true with more complex organizations of groups, of people, where the group itself has different properties than its members. But there's a third one, which I call mixed cognition, where you have part of an overlap. An example of this, which is actually used in the social epistemology literature as an example more of the second one, is that a couple can together know more than its members. So the example is, someone asks, where did you get that statue, to an old couple, and they say, we really don't remember. I know it's been more than 30 years ago since we've had it. The other person says, oh, 30 years ago, that must have been one of those trips. Oh, now you've mentioned that, and they keep on going back and forth, and by the end, they get at the answer that neither of them had separately. Now, this is not exactly a clear situation, of course, because I'm going to use some things. So let's say you have, these are three members, and if you want to characterize the entire system as in joint cognition as a character or system completely reducible to its members, you would just talk about these three members separately. If you're talking about something with very complex relationships that creates an overall character, you would talk about something new. But I think the case in mixed cognition, especially because you're building characters on top of other characters, you could have something more akin to this, where there's an overlap of beliefs of the couple together that overlap with its members, but not everything. And this makes it, of course, a little bit difficult to talk about, which is why I sort of understand why the debate in social epistemology is everything but settled. Okay. So, the last thing I wanted to put on the slide is that we would have essentially unconventional subjects. So human and resource pairs would be allowed as a subject of epistemology, as would be a group of mathematicians, for instance, if that would be relevant to look at it that way. So if it's a very complex interaction, and if the group as a whole exhibits some properties that we can't easily reduce to its members. Okay, so the last two slides is just I want to extract some parameters again, and in this case it would be the system efficacy. This is quite an easy one. It's economy and potential. Economy would basically be as little resources used as possible. This could be just your brain, maybe a mathematician plus some a calculator, maybe some time, some other theorems, some textbooks. As little as you can use will be better for his understanding. Though I think one bit of exception for that is we don't really care if he only uses parts of his brain or a whole of it, because generally speaking, he's always going to have whole his brain with him. But technically it would in my framework be better if he used less of his brain?
I think it would be useful to use less of your brain because you do need your brain for lots of other things.
Sure.
Just understanding mathematics.
Sure, that is true. So
you're so concentrated on your mathematical problem that you don't see that you're going to be hit by a car or something.
Yeah, that is true. But that would mean that the rest of your brain needs to be functional for other things as well. It could also be that you just use a little bit of your brain, but only that is really a good part of your brain. And then you can't differentiate between those two. To end, the last point is potential. This is just something that I wanted to add because there is a difference between someone being one step away from having the abilities and someone who's just nowhere near it. If all it takes is giving some minimum amount of resources and then it would happen, that would be better, I think, than if you need a whole lot of teaching, maybe even brain surgery just to get the understanding. This is mostly for completeness that I've had at this. And that's essentially it. That's the framework that I've discussed. I've gone through the property, the object, and what I think is missing quite a lot in epistemology, some considerations on the subject. There's not a lot of claims that I've made that are specifically mine. I think my contribution is mainly in sort of stringing this together into a framework which allows us to see the forest for the trees and the other way around, however we want to do it. And that's my presentation. Here's my reference list, and thank you for your attention.
Maybe first one general question. The framework you sketch here does not seem to be particularly specific for mathematics. It seems to apply to any kind of understanding.
Yeah, it does. At the moment, at least, I'm very interested in generally understanding, and mathematics is sort of the thing I'll get back to each time I need an example. And when I develop it further, I'll develop the examples more specifically. But I've kept that in mind as well, that I could make something that doesn't necessarily need to apply to mathematics alone. I can always specify later, but if I focus too much on mathematics, I might sort of miss out on some general notions of understanding that would actually have helped if I took that on from the beginning. But that may mean that there was a bit of a misleading title for some people, thinking they would get mathematics, or vice versa.
It may have frightened off some people and attracted some other people.
What makes you interested precisely in understanding of mathematics?
Well, there's a short answer and there's a long answer. The short answer is because I sort of got into a research group that's very specifically focused on philosophy of mathematics. The longer answer is then because I've also read quite a bit via that, and it is an interesting particular of understanding, because scientific understanding seems to always focus on physics, for instance, but I think mathematics is an interesting way to break it a bit open and make sure that you can be general and at the same time specific on mathematics. That wasn't a very well constructed last part, but it's well, I think the answer can be summarized as the field is a bit open there, and there's some interesting things to say that you couldn't say about physics, for instance, because it's a very specific thing that everyone else is working on.
Well, the thing I find most interesting in your approach is the emphasis on abilities, that you understand something if you have the ability not just to reproduce it, but to solve problems related to it. And the wider the scope of the things you can solve related to the thing you understand, I think the deeper your understanding is.
Yeah.
And I remember a small experiment in which I participated a very long time ago, which was done by a cognitive psychologist interested in philosophy of science. You may have heard the name Marc de Meij of the University of Ghent. I think he's retired a long time ago. But so he wanted to test the understanding of physicists, actually, and I used to be still a physicist in those days. So what he did is he showed some physical systems, and one of them was a typical thing with balls that are hanging on ropes, and if you let one ball fall, then the other ball moves. And he said, well, explain that to me on the basis of physical principles. And I did, and there was one or two other questions I had. He said, that's funny, you explain it very well. Most physicists to whom I asked this question can't really explain it. And I think the problem was that physicists may learn a principle in the textbook applied to particular examples, but then if they get a different example that's not in the textbook, like those little balls, they have to be able to generalize their understanding of the cases they know to the new case. And the deeper your understanding is, the easier you generalize it.
Yes.
So that may be a way to kind of measure, in a sense, the depth of understanding. You can understand it so that you can just reproduce this one proof, or you can show that you have more understanding by generating a number of variations of the proof, or you can show that you understand it even deeper by proving some related results. So in that sense, it is this kind of width that the ability of the, you call it, the scope, range, no, range was not the same, but
it's scope, but it's specifically the width and sensitivity.
Yeah. So I think that is very important in understanding, because I think that's one of the reasons why people have difficulty understanding, because if understanding is just being able to reproduce, and obviously it's not different from rote memorization.
Yeah.
But what we mean by understanding, on the other hand, if it's an ability to produce similar kind of results in similar kind of circumstances which are not quite the same, then it becomes much more difficult to measure. And you feel it intuitively, I understand it, because you know, if they put me into some kind of a situation relevant to this, I will be able to deal with it. Well, if you just learn it by rote, you will be able to reproduce this proof and nothing else.
Yeah, that's exactly true.
About that, and feeling, and you differentiate the feeling, ability in the end, something in between. And then you come to the Chinese rule, and you have a Dreyfus quotation, like how can you distinguish, and it uses twice the verb feel in that quote by Dreyfus. So it goes back, like if you want to differentiate the internalized setup of the room, he goes back to feeling of understanding.
It's sort of the disadvantage of this.
So it's this quote?
Yeah. The performer, rather than feeling remorse, can rationalize.
I think this is maybe one of the.
And the learner feels responsible for his own cause. So real understanding of this process goes back to
But I definitely think feeling is definitely involved in understanding. I definitely think that. The reason why I criticize feeling is that feeling is not how we want to characterize understanding, because then we could easily point to someone saying, I can understand this, it feels very, very well my understanding, and then we would have to say, okay, so this person understands, in spite of the fact that that person could not do anything. And we want to sort of keep that at bay.
Okay, but at this point, if it's internalized set of rules, of course, you cannot start with feeling and stop with feeling, but how deep it goes, it's starts to be
of course.
But rather than use the term feeling, I would want to introduce a term that I, in a very different context, defined. It's perceived competence. If you perceive yourself to be competent in this domain, that's usually mean that you have understood this domain.
Yeah.
So that perceived competence, I have afterwards analyzed perceived competence in three aspects. Material competence, which is not relevant for mathematics, which means that you should be able to do it. Cognitive competence, which means that you need to have the right knowledge. But there is also the subjective competence. If you believe that you can't do it, you will not even try.
Yeah.
So there the feeling aspect is, but the perceived competence in a sense connects all of them. Perceived competence means I am confident that I can do it. Maybe I'm wrong. But usually if you think that you can do something, most of the time you effectively can't do it. But there is indeed a probability that maybe you overestimate your capabilities.
But in this particular instance, the feeling is about where you attribute the competence. If it's a set of rules, right? Who is responsible for giving that, and you are just reproducing it, or is it you? How you combine it? So
I think this is
Location.
a sort of case where you this year's field, but I think it's you could sort of replace it with sensing in the more broad terms of you notice that something has gone wrong, but that you have no part in it, in why it went wrong. Whereas
so attribution, like where you attribute the
yeah,
responsibility.
Yeah, I think that's what it is more than really the feeling.
Okay.
Yes.
Yeah, you mentioned social epistemology and group knowledge.
Yes.
And I was wondering if you could say something about the social dimensions of abilities and understanding. Because there is a sense in which a group, as a group, can have the ability of doing something. For instance, where is task delegations. Like you say, okay, you're going to take care of the algebraic parts, and you're going to take care of the geometric parts, and you're going to do the computations. So there is a sense in which a group can have some abilities. And on this, you have all the work by Kitcher, for instance, if you have science, you have work on the task delegations and the specialties in science and how people can...
Send me that, because I haven't read the...
You haven't? Okay, I'll send it to you. I think it's more in the social epistemology of science than in the social epistemology in traditional mainstream epistemology. But for understanding, I'm wondering if understanding really applies to a group. I think it's very unnatural to say that. Attributes understanding, saying this group understands that.
I'm not saying yet that it will exist, that I could give specific examples of this, but if groups would exhibit abilities that neither of their members can, then we have to give the understanding to the group rather than to its members. That's the point I'm making here, and then now I'm interested in, does this actually happen? Because I haven't investigated this.
But my intuition would be that it makes sense to attribute abilities to a group, but not understanding at the level of intuitive understanding of understanding, so to speak.
Yeah, I think there's an intuition that understanding is something that, first of all, only humans can do, and just humans as the unit itself. And I think that's an intuition I want to fight, because if we really develop our account of understanding, we have to be consistent, of course. If someone wants to challenge me, this is not a good characterization of understanding, then I'm willing to argue with that. But just the intuition, but groups shouldn't really understand. I think this might be chauvinism a little bit. That's that would be okay to fight.
There might also be a connection with the idea that we associate understanding with a kind of an aha element. Suddenly things fall into place. Now I understand. Which with a group it's kind of more difficult to imagine.
Yeah.
Because a group will always, to some degree, behave asynchronously, and different people will get different things at different moments. So it's not at one moment that everything comes together.
Isn't this aha moment not also missing from your account of understanding? I mean, if
I didn't catch the first part, sorry.
Isn't the aha moment not also missing from your account of understanding? So if understanding consists of having certain abilities, and the more abilities we have, the better we understand, at which point where do we account for the aha moment of, now it clicks, now I understand the proof, now I really see why this works?
Well, partly I just sideline it as not part of my object of study, in a sense, because the aha is definitely associated with understanding, but it's not the notion of understanding that we value necessarily. It's involved in it, but what we value about someone understanding is not the person having the aha moment, but having the abilities. So if we would have two options, someone says, I have the aha moment, but I don't have the abilities, we discredit that more easily. But someone who would have the abilities but not the aha moments, we wouldn't say, oh, well, then it's not really understanding.
So your account does not, this kind of, how to express this, so you want to account for us thinking about others having understanding rather than giving an account of self-perception.
Yes.
When do I have understanding?
It's more about assessing understanding than it is about
self-assessment.
Yes, self-assessment. I mean, self-assessment, sure, but not in the psychological sense of feeling that I've understood. It's more maybe what goes prior to this, the things that you either consciously or subconsciously are testing to see whether you understand. And that's the thing that I'm really focused on.
But I think there is a contradiction between the ability approach and the aha LLM, because what is the aha? It means that you have some elements of the system in your mind and suddenly they fall into place, which means that suddenly they become a functional whole. The aha is that the ability appears by fitting the things together. It's like a machine that's in separate parts. You put the parts together and at a certain moment the machine starts to function, starts to have the ability to solve problems.
Sure.
So the aha is just the moment when the last part clicks into place and you have the develop the cognitive machinery to solve, to have the abilities.
Yeah, or to nuance it just a little bit to the moment where you notice that it's fallen into place. Because sometimes it may have already fallen into place and all of a sudden you realize, oh yeah, it has.
Yeah.
Now with everything.
Yeah, as it's shown by cognitive science, is that a lot of that happens subconsciously, even while sleeping. Those connections are being formed, and then the same thing that you learned the night before, you had the feeling that you didn't understand, and then the morning after you start thinking about it, actually it's not that difficult now, I see much better how it fits together.
Yeah.
I think the talking about fitting together, it's quite interesting, but that's maybe this is I was thinking about the social dimension of understanding.
Yeah.
Because so yeah, we heard the talk a couple of days on philosophy of experimentation, and I don't know the term in English, but it's the microscope as balayage in French. So there was a technology that at the beginning people really do not understand, and it took several years for the instruments to be accepted into the physicist community. Physics community, and you see that the way it has been accepted, the person was arguing is that there has been various strategies for getting some knowledge about the reliability of the instrument. And it seems that you might somehow say, now we understand why it works, so that the community as a whole understand why it works, and this understanding would be a sort of lots of elements coming from different directions, lots of results that kind of confirm, goes in converge, so fixed together, converge in certain directions. And in this sense, maybe we can say that the community understands now why the microscope built in this way worked, while before they were very puzzled by how it worked. So yeah, there was just a suggestion that the social dimension of understanding could be something like various strategies put into the same direction at a certain moment.
Right. That's interesting to think about. I don't have any response to this yet, but that sounds interesting.
Yeah, but I think if you define like approach understanding as ability, attributing such understanding to even more abstract social systems and groups, it's not very difficult because like mathematics as a system has a grasp of some kind of reality, right? So it can as a system.
But it has to be implemented by something. I mean, we're not talking about abstract things understanding.
Yeah, but any system has to be implemented in order to operate.
Sure.
So a human mind also has to have some blood pumped to it, right? So and then as a system, it shows ability, right? So like the scientist community, now they are able to use the tool.
Well, yeah, I've sort of put that under groups in my mind, so I didn't necessarily distinguish this from.
Yeah.
I think we can find some example in mathematics too, where they study certain objects from different perspectives, and that somehow we gain an understanding of a certain mathematical phenomenon. Maybe this is connected to the discussion about explanations in mathematics. So that I think is such a phenomenon. You can probably find some cases, of like various directions in various branches of mathematics talking about somehow the same object and somehow converging, and that the understanding comes from there. So there could be some kind of equivalent perspective where we have to.
Yes.
So in your account, since you assess a lot, right? So you want to assess the other. There's this feeling of measurement, right? You want to measure somehow their understanding. So this was your bid for ability. So you want to sidestep feelings because we can't track them. We can't measure them in some sense of measuring.
Well, we're not sidestepping feelings just to measure because of the measurement, but also because it's not. But maybe you mean the mental representations that you can't measure.
Perhaps I also mean the mental representations.
Okay, I'll let you continue. I'm sorry.
It doesn't matter too much. I mean, so I think this permeates your whole account, right? You want to have a certain grip on the understanding of somebody else. Are you claiming that this is all there is to understanding? So all there is to understanding is something that I, as the external person, can assess in somebody else? Is that all there is to understanding?
No.
Is that all there is to your account of understanding, that that there are certain measurable parts and we are interested in those, and there might be others as well? What is your take on that?
Well, what I'm trying to do is sort of grasp the idea of understanding and then link that to measurement, because obviously there's things that I've mentioned that you can't explicitly measure, because for instance if you're saying understanding is counterfactual performance, you can't really measure counterfactual performance. But the short answer is I'm trying to be as exhaustive as I can without claiming to be. Because, well, this is the beginning of my PhD, I might still get a lot of sort of critique for what I'm doing, but I'm trying to be as complete as possible without claiming to be.
I don't have such a problem with the counterfactuals if you interpret it as potentiality. That is, that person is potentially able to produce a proof in these and these circumstances. If you have a wide range of circumstances in which he can produce the right kind of proof, you can say he understands it. And that applies both for himself. He himself, when he feels he understands it, he will also have the feeling that he can produce the proof in different circumstances, and for the outside observer. So there is not necessarily a contradiction between those.
No, but it's difficult to determine. I like the example. I mean, counterfactuals are of course a general problem for science as well, because you want to know how it would have been different if circumstances were different, but you can never really look at the counterfactual world. If you say my car can go 50 miles an hour, if your car is not going 50 miles an hour, you're already making a counterfactual statement. You're saying, had I pushed harder on the pedal a couple of moments ago, this car would have gone 50 miles an hour, but you can't really prove this. There's always a little bit of a difficulty, but I think it's not as big as it might seem, of course, because it's something we deal with all the time.
Well, it reminds me of how Einstein defined an element of reality. Einstein was much upset with quantum mechanics, so it seemed to reduce the world to purely subjective measurements. So he defined an element of reality if some physical system has a property so that you can predict with certainty that if that system is put in these circumstances, it will react in that way. Except if I can do that, that property has an element of reality. So in your case, understanding would be an element of reality if you can predict that if that person is confronted with that problem, he will solve it.
Yes.
So
I mean,
even in this kind of pretty realistic view of Einstein, you could claim that that there is an element of reality in your notion of understanding.
Sure, it's just that sometimes there's a lot of variables, but
yeah, of course.
But that is
the
of
world
course
is much more complicated than the world of physics that Einstein was speaking about. But I think the philosophy is the same.
Yeah.
It's part of how our knowledge functions. We say that something really has a property if we can use it to make reliable predictions. If we can say that guy really understands, let's say the theorem of Pythagoras, because I know that if I ask him these and these questions, he will solve it correctly. It's a prediction you make about how somebody would react in circumstances that have never happened before, so counterfactual. But you know that if you put him in that situation, he will react in that way.
That is at least the general idea, yes. Anyone else a question or a note or criticism?
Well, apart from the idea of ability, the most interesting part of your talk for me, of course, is the idea of the distributed understanding or the socially extended knowledge, because it's a topic I'm also working on a lot. So I quite liked your example of the couple that together know where the vase came from, but wouldn't know them either alone, and wouldn't even know that if they would each write down everything they know, and then somebody else would put it together. Because I think that's a very nice example of how it's not only the knowledge that is distributed, but the process of inferencing that is distributed. Because you need to get the piece of knowledge from the one to come to the piece of knowledge from the other one, and so on. And it's an example I may actually adapt for the paper I'm writing, so I will remember it.
Isn't it a situation a little bit like you have actually a simple copy machine and afterwards a deterioration of each of elements? Because you lose memory on both sides, but you had a simple copy made. How does this play into the system?
But it's not just redundancy. I mean, if it could be redundancy, that each has part of the solution and part of it overlaps, and you just say puzzle all the copies together, and you will reconstruct the manuscript.
Initially you have redundancy because it's doubled.
Yeah.
And then you have deterioration. And then it's completion because of the proximity.
Well, in this particular example, you start with redundancy, but I think you can generalize that example for people who have different knowledge.
Okay.
Like you might have a mathematician and an engineer and a physicist, and together they can design a solution for this problem, but none of them can design it on his own.
The idea that I had, that was mine, but I wasn't confident it is that you have someone who basically, someone is a really big fan of Star Wars and someone is a really big fan of Star Trek. Neither has seen the other, but they together get questions about how Star Trek and Star Wars are related or different, and they have to communicate together, and they say, well, Star Trek is set in space. Oh, this is the same thing with me. And then it says it's about big philosophical ideas, and then it says, well, Star Wars is not really like that. And through the process, they sort of can answer questions that they wouldn't be able to answer separately. Maybe that is a better example.
I think we should be able to find an even better example. I should think about it. Well, I gave an example in my paper that was not completely convincing, where you have a company that gets a question from a customer, and the guy who gets the question says, that seems to be a question for this department, pass it on to this department. Then they say, but in order to solve that question, you need to know about that, so they pass it on to a third person. That person says, but that requires that I need this more additional information which I get from this person, and like that it kind of propagates to the company, and in the end they get a solution to the customer's request, but nobody actually knows the answer.
Because these contribute parts of it.
They need. It's not only that that the different elements of the answer are distributed over different people, but also that they need to know the paths to which it needs to follow in order to find all the elements of the answer.
Because it's not just each one filling a piece of it in, it's someone maybe reacting, that part doesn't really make sense with mine, so I adapt this a little bit, and then in the end you get an answer that none of them really can give.
Is this not why we have think tanks? I mean, think tanks you bring together lots of differently educated people to think together on the same problem, but the idea being that they're more or less in one room. And I mean, I quite like the example of the mathematician, the engineer, and the physicist. Right, and you can probably expand this and make it bigger and become something like a think tank.
That's true, I think. Yes.
What the think tank has an understanding as a whole.
But it depends how the think tank operates, of course, because if they just sort of each from their own discipline sort of dump data at one another, that's not really going to help. But if they can respond to each other's notions without really maybe fully understanding what the other person is saying, then the think tank as a group may have indeed understanding that neither of them has separately.
So then we have also a global brain.
Sure.
Okay.
Well, if it's implemented such that it
the moment the global brain does not have a very deep understanding yet, but potentially it
might have a feeling of understanding already.
A perceived capability.
We should have lofty understanding, right? I mean, if we take the picture seriously, the big bubble is on top, right? So the understanding doesn't go deep; it goes lofty, it goes up.
Your different pictures, I wasn't quite sure when they depicted very well these kind of things.
Yeah, it's just a way of thinking about it, but I'm still looking for it.
I tend to describe distributed cognitive systems more kind of like networks with arrows, where you see that some information comes in some people and then gets combined in other people and comes together in other people, or computers or books or other things. But I think we really need to develop a good example.
The reason why I do it this way is when we talk about humans in general, we're trying to characterize things that they understand. For instance, we may talk about their beliefs. We don't talk about how their brains are necessarily parsing information and doing this and that. We can also talk about this as a virtual entity and talk completely in those terms. And that's why I have the sort of bubbles. For some systems, you could just describe it in terms of its parts. For others, you create a different entity floating above it, and it makes it easier to talk about it. That's why I sort of did this.
I suspect one of the reasons why philosophers like to speak about beliefs is that beliefs is easier. It kind of just looks like a single thing that's there or that's not there.
Which is of course
while understanding, even though it looks as if it's something there, it's really this ability which is really a way of generating processes in different situations.
But even beliefs, I think, breaks down into some problems, because some philosophers like to just think of it as propositions that are in their head, but obviously beliefs don't work that way. Beliefs are also...
No, they don't work like that, but it looks as if you can represent them as propositions, and of course propositions are easy to work with.
Yeah. But even beliefs I would tend to characterize more in terms of maybe not abilities, but certainly the way the person behaves, rather than something being in their mind that we can then sort of point to. But it's a useful way to talk about people. It's a sort of shorthand. It's not perfect, but it works to bring some intuition into the conversation.
Is I don't know, this could be of interest to you, but in the formalification of mathematical proofs, there are cases where they bring different proof assistants to get to the proof. So for instance, if you look at the Kepler conjecture of Thomas Hals, so most of the thing has been verified with whole light, but there is a part that's been verified by Isabel. So on the generation of graphs. So actually, the formal proof is combinations of two proof assistants with different architectures, providing the last results. In terms of distribution of, Alligator also talks about the computer understanding the proof in his paper. So it's another instance of understanding. What he has in mind is a model of the proof assistants. So for these examples, you have the computers understanding the proof, but with the social dimensions, because you have two different computers together that understand the proof.
Yeah, that's where I want to get at the end of my PhD, because I'm developing this to then look at things like automated theorem provers and such, and to see to what extent they can understand something. And the social dynamics is I think interesting, especially because you distribute it. There's even I've forgotten the name now. There's I think it's an automated theorem prover, and it works a bit by having different pieces of software trying to do things separately and communicating with one another, which I think is very interesting for something like this. But I have to still do the work for that.
Because there are not many examples where they brought two different assistants together. And the Kepler one, I don't have in mind. Usually they do everything in one group assistant.
Could you send me an email with specifically what you mean? Thank you.
Because a traditional approach in artificial intelligence is you have distributed artificial intelligence, different agents, each with different skills that exchange information via what's called a black board. They post the results they get, and then other agents look at the results and see what can I add. It's an application of stigmergy. It's a method to solve collaboratively a problem without having to have very specific coordination or communication between them. They just post their provisional results, and then the others look at those results and see, can I add something? And
this is exactly science.
yeah,
Perspective.
exactly. Science also works in that way.
Which is also why it's interesting to postulate whether there are groups of scientists that, as a group.
There's the recognition.
Yeah.
I liked really Nancy's idea of, if you want to assess understanding, of course it's very difficult to create a model, but there is incredible high percentage of accuracy if you see the simplicity and brevity of someone who understood and explains, as you said. It seems like, if you get to simplicity about something, it's probably a good sign of having this understanding.
An explanation, of course.
Yes, and that might fit in with the rule book of Searle. Why don't we think that rule book approach doesn't feel like understanding? Because if you want a system like that to work, it would be such an enormously long series of rules that there would not be any coherence in there. While with understanding, you have the feeling it's kind of a coherent system where, as I said, the different things click into each other, so that you have kind of a common core with lots of rules and applications, but where there is some kind of a coherence that gives it a simplicity and unity.
I think the opposite is true as well, actually, that because he in a way assumes that we could write it down in something that's basically book size, and you couldn't do that.
Which is completely unrealistic to write down Chinese in a book in a way that you could answer any Chinese question.
And then it seems that this can't be it. And I think that's an intuition that's also comes out with his example that's a bit misleading because of it. Bennett criticizes him for this. It says, it's easy to then think that it won't work, but if you really were to think about how complicated it would be to do this and the enormous amount of instructions that you would need to go through, it becomes less and less strange that there's something that you're implementing that does understand, rather than just certainly using the rule book.
Yeah, the rule book is a very unrealistic example, as if you could ever understand real world questions in Chinese and just follow a book and answers.
Anyone else?
No more questions? Well then, thank you again.
And thank you for allowing me to speak here.
It was a very interesting topic, so I think it's a good start. So
thank you.